So you say this one, we say x plus 1 over 3x minus 2 minus 4 over 1 less than 0. Get 3x minus 2 as a common denominator of x plus 1 minus 4 3x minus 2 less than 0. Have it expanded, so get x plus 1 minus 12x plus 8 over 3x minus 2 less than 0, giving us negative 11x plus 9 over 3x minus 2 less than 0. Then we get critical values. So we say negative 11x plus 9 is equal to 0, giving us negative 11x is equal to negative 9 divided by negative 11 divided by negative 11. So x is equal to 9 over 11. Also 3x minus 2 is equal to 0, giving us 3x is equal to 2 divided by 3 divided by 3. So x is equal to 2 over 3. So we have this also. We also have this. From there, we are trying to compare which one is smaller than the other. So 9 over 11, if you divide there, you get 0.
So I have a question before.
Yes.
The solution set, is it the same if we were to say negative infinity 3 over 7 union 3 over 7 to infinity?
The number here is different.
But it's included.
Yeah, then there's a gap. There's a gap in between.
All right. Okay.
That we are leaving out.
All right. So.
Okay. So 11 into 90. We know 11 goes into 88. 8 times. Remainder 2. So when you place a 0 there, 11 goes there once. So let's hold it there. We come to 2 over 3. This is 0 point. Place it as 0. 3 goes into 20 8 times. Is it 8 or 6? 6 times. Oh, there's no need of panicking. 6 times. So 2 over 3 is less than the top one. Yeah. 2 over 3 is less than 9 over 11. The trick part will be getting a number in between. If you get in terms of fractions, it will be trick, but you need to add them. So 2 over 3 plus 9 over 11. This will be 33 down, and then 10 by 2, that's 20, plus 3 by 9, that's 27. So we get 47 over 33, and then multiply by half. So we get 47 over 66. 47 over 66. A number bigger than 9 over 11 is 1, less than is 0, and then get negative 11 x plus 9. Also get 3x minus.
So 3 into 33 is 11, not 10.
It's not 20, so it's 11. Yes, 22 plus 27. Supposed to be 22, sir.
22. Okay.
Yes.
So that's 49.
Yes.
Oh, so my
49.
discount.
Okay. So it's 49.
Bros, guys, when I say at least a cocoa or my potential, I think I am a cocoa.
Okay, then if we take so of negative 11x plus 9.
So where has the 1 over 2 come from?
X minus. So how do we get the number in between? We're looking for a number between 2 and 4. So we add them, 4 plus 2, we get 6, then divide by 2, we get 3. So we find that 3 is indeed in between 2 and 4. And dividing by 2 is the same as multiplying by half, is it? That's where the 1 over 2 is coming from. You only do that if there's no whole number in between the numbers that you have. Okay. Then we test 0 here will give us positive minus, so we have a minus here. 1 will give us a minus, a positive, so we have a minus here. Meaning that the other guy must give us a positive here. So let's test negative 11 multiplied by 49 over 66 plus 9. This will be 1 here, 6 here. Then 6 down, negative 49 plus 6 by 9 is was 9 by 5 is 45. So 9 by 6 is 54. So we get a positive number. So positive. Then again 49 over 66 multiplied by 3 minus 2. This will be 3 there, 1, 3 here. 22. So 22. Yeah. This is 49 minus 44, which is positive. So multiply the two positives, we get a positive. What we have is less than 0. So we get the solution set 2 to be negative infinite all the way up to 2 over 3, not including anything, 9 over 11, positive infinite. So our final solution set will be solution set 1 intersection solution set 2, meaning negative infinite 2 over 3. It doesn't matter how I write them here, but because I've already put that order, we need negative infinite, comma 3 over 7, union 2 over 3, comma infinite. This intersection, negative infinite 2 over 3, union 9 over 11, comma infinite. So that getting the intersection now, it's a bit nice here. Between this interval here and this interval, consider the left numbers, negative infinite and negative infinite. Get the biggest, but here they are the same. So get negative infinite. Then between the inner numbers, 3 over 7 and 2 over 3, get the smallest. So 3 over 7 and 2 over 3, we say the smallest is 2 over 3. So you get 2 over 3. It's not included. Then you use union now. Between this piece and that piece, between 2 over 3 here and 9 over 11 there, get the biggest. And we just say that the biggest is 9 over 11. And then between infinity and infinity, get the smallest. Now the two are the same. So this becomes our solution set. So that's how you obtain that solution set there for such a type. So that the other type on this one will be example 3. Still solve for x. A, the modulus of x plus 1 is less than 4. Now remember that we defined the modulus in 2 pieces. We said this same modulus, x plus 1, is the same as x plus 1.
Diversity a little bit. All right. Thank you, sir. Thank you very much.
And we said the same is negative x plus 1 if x plus 1 is less than 0. This means that that same inequality has x plus 1 less than 4, or in fact not or, and negative x plus 1 less than 4. Okay, now here we don't do in trouble, so we have options. And then this means that we have x less than 4 minus 1, giving us x less than 3. Here we have negative x minus 1 less than 4, giving us negative x less than 4 plus 1. So negative x is less than 5. Divide by negative, would get x greater than negative 5. And then, so here we have 2 pieces, 5 going this side, and the other one is from 3 cosine. So it's true, meaning that here is supposed to be and yes. So you get the solution set to be from negative 5 to 3. That means we can easily solve this question by simply saying negative 4 will be less than x plus 1, which will be less than 4. On the other side, take on this side. So we have negative 4 minus 1 less than x, less than 4 minus 1, gives negative 5 less than x, less than 3. This is what we have here. So whenever it's less, the modulus is less than. That's what you do. So that B, if the modulus is
No, so question.
okay.
So you have got the x plus 1 in the modulus form, which is the modulus of x plus 1. Well, then we did you just consider the rest numerator?
Yeah.
Well, I understand what you mean by the less equality. The idea is not to solve for the modulus. Then the modulus help us solve this inequality. That's why we are saying since it's positive when it's positive there, and since it's negative when we have here, what we'll do is we'll just borrow those 2 definitions, but still fix the less than 4. Since you only have 1 inequality there. So those 2 definitions will both be less than 4. But what will help us after this, not to have the same thing, is the fact that this are not negated. And we do anything by negative, then it changes. So that's where we get our differences, yes. Then B, whenever you have x or 7 in the modulus, anything in the modulus less than a negative number, the solution there is empty without solving, just say empty. Why is it empty? Because the modulus is meant to make a number positive, so it can never be less than negative. Since all modulus outputs are positive, and there is no number, there is no positive number, there is no positive number which is less than a negative number. C x plus, even if I say negative 3x plus 1 greater than negative 3, the solution set here comes all real numbers based on the same property, because negative 3 will always be less than any positive number. So it's true that what is the modulus will be bigger than negative 2 for any value of x that you in the modulus. So it is, then D, the modulus of x plus 1.
Just a minute.
Sorry, just a minute, I finish copying.
So there is no need of solving.
There's nothing to solve.
So you can find the modulus of that expression right there.
Yes.
Even if you find it to be bigger than negative 3 for any value of x.
So
Done, thanks.
when you just express it like Oreo, then that's the modulus.
No, that's the solution set, not a modulus.
Oh, so
So
we're
what's
not determining.
No, the question is asking for solve for x. So for what values of x would
So
this
it's
invalid to be satisfied? For all values of x.
What are you saying? What are you saying?
So is it the
solve
same
it
as
E.
is it the same as if I solve for the value of x and expressing it like that? It's the same thing. It means one and the same thing.
Yes.
Sir,
So, but won't I lose marks by leaving it right there without solving it?
There's nothing to solve.
sorry, I'm a brony.
What's the difference between question B and C?
Question B is saying the modulus is less than negative number. We are saying it's not possible. So there's no value of x that can make the modulus to be less than a negative number. Question C is saying the modulus is bigger than a negative number. We are saying that is true for all real numbers.
All right, thank you.
It's like they tell you to complete the square. They say complete the square of f of x is equal to 2x squared plus 4. What do you say? It's complete. Full stop as your solution. Then you ask that, do I lose?
Complete.
It's already complete. What is to complete the square?
It's
is to put a number in this form. But it's already in that form. So it's complete. And you get 5 marks.
He's lost.
we might see a paunza. No, we know.
And
that was
this question was there in the quiz. Complete a square of that. And then because you like solving, you start solving. I don't even know what you can solve then.
But sir, even if you solve again, you're
Some
going to
maths
get
is a day of
that's why there's
So, sir,
nothing to solve. Yes.
For instance,
yeah, so where is only B you
Or
put
cross the other
0x
side.
side.
Then it will not work. This one will be negative.
Wait.
It will not work. This one will not work. This one will be a negative.
This one.
This one.
This one.
Hmm?
This one.
No, sir. For this question, when we determine the values of x, here we they are all real. This one is positive. But why can't you just show it like this, just by solving at least?
There's nothing to solve.
Then you conclude by saying Oreo.
There's nothing to
please,
solve.
sir, wait.
But it's wait.
Well, when you solve that equation, you're going to get 8x greater than 4 over 3.
4 over 3.
Then another one, you're going to get x it's greater than -1. So can't you solve it in that way? No.
Look, if you say -3x plus 1 is greater than -3,
Yes.
and I mean for this one it's greater, we say or -3x plus 1, we give it a negative, is greater than -3. So there on top we'll have -3x greater than -3 minus 1, which is -3x greater than -4. Divide by -3, divide by -3. So x is less than 4 over 3. Or you expand here, you get 3x minus 1 is greater than -3. And then take this guy the other side. Let me see. It will be 3x greater than -2. Divide by 3, divide by 3. X greater than -2 over 3. And then if you get the union, it will be in fact it won't even make sense, because our solution now should be this guy is saying from -infinity up to 4 over 3. Okay, to make sense here. Union, the other one is saying from -2 over 3 up to infinity. You can see that this guy is starting from here inside. So you get -infinity up to +infinity.
Yes, which is Oreo.
Yeah, now look, when we set these questions for people to answer, the examiner allocates marks for each, allocates minutes for each question. Because when you set 4 questions and you say answer all, and the assessment is for 2 hours, the examiner should be able to answer these 4 questions within an hour. Then they assume that a student will answer within 2 hours. So they double the time. Now what happens is that when answering such a question, the examiner's time will only be a second, because you just say solution set is equal to R, full stop. Or they add maybe another seconds to give a reason if they so wish, and move to the next question. Then you come and spend the whole time solving his and give this solution for maybe 2 marks. And then you have other questions to solve. At the end of the day, you don't finish. and then you say it was bulky. When you chose to solve, even where there was no need to solve.
Oh,
Yeah,
so
it
you're
makes
right.
sense now. Yeah.
You're right.
So in short, we need to factor.
to factor.
Oh,
It
okay, it really makes sense. They give
Now,
us
sir,
they give
sir,
us hours
I've
to
got a
think.
question.
Yes.
So, how do we identify and how do we know it's all real? How do we identify?
No, we know
Sir,
that the
I've got a
definition of
question.
modulus is always positive.
Yes. Sir,
Oh,
I've got a,
yes, sir. Okay.
on the interval negative infinity, why use negative over there? In that in the interval.
No, this one, we got this. X is lesser. So if we have 4 here, X is less than X is this side. For this one, X is greater. If you have 4 over 3, X is greater. It's nothing.
All right. Wait a minute.
The interval. If you have this greater than 5, this is greater than now. So notice that the first one was less. I brought in this property. Then the third one, before one, is equal to x plus 1 or x plus 7 greater or equal to 5. Or the same way we find this one here, and this. So the negative 1, negative x1 or x plus 7 is greater or equal to 5. Now here you have, if you should divide the negative, the negative what we have is x plus 1, x plus 7, let's go to negative 5. Telling us that when x greater or equal to a, we must define in x negative a or x greater than a. That will simplify our in general. So here now we have to solve. Solving for 1, x plus 1 over x greater or equal to 5, and 2 x plus 1, x plus 7 less or equal to negative 5. So we have these will be solved 1 and 2. So for 1, it's x plus 1, x plus 7 minus 5 over 1 equal to 0, which is x plus 7, x plus 1 minus 5x minus 35 equal to 0, and then you get 4x minus 2 over x plus 7 greater or equal to 0. The critical values, you get negative 4x minus 34 is equal to 0. So negative 4x equal to 34 divided by 4 divided by 4. So x is equal to 4 16 over 16, 17 over 2. And then x 7 is equal to 0 will give us x is equal to 7. In fact, even this one is negative. Okay, yeah. Then you test. So in testing, we have negative 17 over 2, and then negative 7 because negative 8 is in between, and then 0 is either, negative 10 is over. And then you have negative 4x minus 34 because of x plus 7, and then you say shed. So it's negative 10 here, you get negative positive 40 minus 34, and then negative, and then negative 8, you get positive 32 minus 34 is minus positive, and 0 will get minus positive minus. Now we have equal to, so we get solution set 1 to be negative 17 over 2, comma negative 7. This is coming down, this is in red. And then x plus 1 or x plus 7 plus 5 is equal to x7, x plus 1 plus 5x plus 85 is equal to 0. We have 6x plus 86 over x plus 7 is equal to 0. 5 and 6, x is negative 36. By 6 to get x is equal to negative 6. So we have negative 7, negative 6 is 0 bigger than negative 8. So now we're doing negative 0 bigger than 13, divided by 2. And then it's 6x plus 36, then x plus 7, then because negative 8 here, it gives us negative, sorry, positive. Then this 0, positive, meaning is negative, 0. So we find it less than 0. So let's solution to be negative 7, negative 6. So we have to get this, it's all. So you get unknown solutions, or set solutions, we know solution 2. That is negative 17 over 2, negative 7, you know, negative 7, negative 6. And again, there's no find for intervals, not intersect. Yes.
What happens if you write those tables, two tables, one another? Then you just tick one without saying that, like the section. Is it okay or what? Then
you tick where you want. Oh, you do the same thing here. You tick.
Yes, sir.
And do this. Then you get there.
Okay, so just like that, is it?
Oh, you must understand how to read the tables.